Mobile Communication Lecture Series Session 2. In this session we are going to see about the frequency reuse and the advantage of frequency reuse concept. First of all, what is frequency reuse? Frequency reuse, it's based upon the cell. First of all, what is cell? A service area is split into small geographic areas. That one is called for cells. Each cell or base station is allocated a group of radio channels. Each base station in different cells are adjacent different channel groups. The definition of frequency reuse. The design process of selecting and allocating channel groups for all of the cellular base station within a system is called frequency reuse or frequency planning. So this is the definition of frequency planning or frequency reuse. By limiting the coverage area of base station, the same group of channels may be used by different cells far away. So this is the advantage of frequency reuse. Some standard cell shape. In this figure, clearly explain what are the different type of cell shape available in your mobile communications. Square, equilateral triangle, hexagon. Generally we have used a hexagon shape. Why we go for hexagon shape? Because that one is provide for the entire region without overlap and with equal area. Geometric shape covering an entire region without overlap and with equal area. By using the hexagon, the fewest number of cells can cover the geographic region, and the hexagon closely approximates a circular radiation pattern which would occur for an omnidirectional antenna. Two different type of excitation modes. So the first one, center excited cell, and the next one for edge excited cell. What is center excited cell? The base station transmitter is in the center of the cell. Omnidirectional antenna are used in center excited cell. Edge excited cell. Base station transmitter are on the 3 of the 6 cell edges. It's like wedges. Sector directional antenna are used in edge excited cell. How to calculate the frequency reuse factor? The concept of clusters. So here I consider a cellular system which has a total of S duplex channels available for use. The S indicate for channels are divided among n cells. The n cells it is called as a cluster. Each cell is allocated a group of k channels. Then find out the total number of available radio channel. It can be expressed as capital S equal to small k and capital N. The capital S indicate for total number of available radio channel, and then k indicate for each cell allocated a group of k channel, and then capital N denoted as cell size. It's like cluster. So in this figure clearly explain K is indicate for the group of channels, and then N is 7. So N is 7 is indicate for cell size. It is a cluster. Generally we have using cluster size 4, 7, 12. The commonly we have using 4 and 7. Frequency reuse factor 1 by N. Reuse planning. So here m number of times the cluster is replicated, then how to calculate in your C values or the duplex channel, total number of duplex channel C values. So if a cluster is replicated m times within the system, the total number of duplex channel C can be given as C equal to capital M, small k and capital N. So we have already known Kn is denoted as S is like a total number of duplex channels. So that's why I apply M into S. Then how to calculate N values in mathematically? N equal to I square plus Ij plus J square, where I and J are non-negative integer. The nearest co-channel neighbors of a particular cell can be bound by doing what follows. Move I cells along any chain of hexagons, tan 60° counterclockwise. Move J cells. So in this diagram, explain the examples of reuse planning or frequency reuse. So the first one, the cluster size n is equal to 7 cell reuse, and the next one 4 cell reuse. So in this diagram, 7 cell reuse, A, B, C, D, E, F, G, R is 7 cells, n equal to 7. Here I have using two non-negative integer value, I value is 2, J value is 1. Just I apply the formula of n equal to I square plus Ij plus J square. Then finally I got the n value, n is equal to 7. And the next diagram, n equal to 4, A, B, C, D. So these are all 4 different type of cells, n equal to 4. Just I apply the mathematical formula or mathematical calculation, n equal to I square plus Ij plus J square, I value 2 and J values 0. Finally I got the value for n equal to 4. This is another one examples of frequency reuse, n equal to 19. Cluster size is 19. The A indicate for frequency reuse. So here I value is 3 and J value is 2. Finally I got the value n19 from n equal to I square plus Ij plus J square. And the next one, the advantage of frequency reuse. To improve the total system capacity without the need to employ high power transmitter. And the next one, the same spectrum can support multiple users separate by a distance. So these are all the two important advantages we have using in your frequency reuse. Thank you.